Harsh, basically working as a principal data scientist at Micron Technology under SMAI team, basically smart manufacturing and AI team. And today's topic will be text-to-SQL. I think it's one of the most interesting use case of LLM once LLM starts maturing. And till the time this paper was written, it was last year around October or November, and there are further enhancements which has been done already on the architecture and everything which I'm going to show here. But yeah, I will discuss about those in a few minutes. So let's move forward with that. So the agenda here is basically I will start with the introduction. What is the problem statement? What we are trying to achieve over here? And what is the target audience basically? Because the target audience for this kind of solution can be a software developer, for a database, or a database administrator, or a stakeholder, business stakeholder as well. So I'll start with introduction, then I will quickly move to solution architecture, how we have developed it. Then within solution architecture, I will do a small deep dive, brief deep dive on the methodologies, what all we have done. Then the results, what we are getting. Post that, we will be having the limitations of this one and the scope of improvement, which I already talked about, like what we are implementing as of now. Last is the acknowledgement, what all other team members are involved, how they have contributed and where, because the domain expertise is required where you are enabling it. Maybe procurement, supply chain, sales. So those domain expertise is required for other people to get involved. So let's quickly start with that. Okay, to start with, the problem here is how a user can ask a question, basically in a simple English language, and a bot, maybe a bot or an application, can take that question, understand the context of the question, and get us the output in the form of a SQL query. And obviously, we can run SQL query in the second step, in the second iteration, and get us the results from the table. That's the whole idea behind this. But as I told, the target audience can be different. For us, the target audience were business stakeholders. The reason being, we are actually dealing with billions of spends, and we have a lot of solutions, reportings, analytics, dashboards built on top of that. Now, those dashboards, reporting solutions are heavy in nature. Most of the time, people navigate between those solutions, download the data from there to do their analysis, because all of the analysis or all the metrics, as and when required, cannot be displayed on the dashboard. And I think most of the engineers might have faced it. Stakeholders will come and ask, can you fetch this data from me, from the dashboard, or from the SQL, or from any relational database. So that takes time. And that is, you can say, it's an irrelevant piece which should be removed, because it is not even giving you any additional knowledge. You are just writing a SQL query, pulling out the data, and sending the numbers to them. So reducing or removing that part is the main goal here. And since as I told, we have a huge number of dashboards and reporting solutions, so the target is that. So the problem statement here is, can we build an application which can help in quick retrieval of insights from the reporting solutions, be it the UI can be in React, Angular, Tableau, or any other thing, or Power BI. So from the relational databases, with the help of basically, the stakeholders can come and ask question in the natural language, or be it a simple English language. So what we have done is we have used this LLM. Our solution is hosted on GCP, so we have used LLM to build a chatbot kind of thing, and it is dynamically hosted. I will tell about that later. And it is integrated among all of the dashboards, all the reporting solutions which we have, where users can directly come, and instead of navigating or downloading the data for small informations, and instead of basically reaching the developers or the SQL guys, they can quickly ask their questions and get the relevant information out of it. That's the whole target here. So moving onward, I'll start with the solution architecture. The first step in the solution architecture is the data ingestion piece here. We have created a lot of few short examples. When I say few short examples, what we have done is we have created some questions. We have asked user what kind of questions you generally ask. We have recorded them, created correct SQL queries from them, and stored them in a vector database. So this is what is shown here. You take documents, we call them as QA pairs. We do convert them into embeddings, generate embeddings for the questions, only for the questions, not for the SQL queries, and store it in a vector database. Now, the second step is basically, you can call it second step or the last one. This is the UI kind of thing where user can come and ask. So when user asks a question, the question gets converted into the embeddings. using the same model which is being used there, and with the help of vector database, you actually calculate the similarity score. Now, let's move forward. So I will be honest here. AI cannot generate on its own. You need to provide data to it. You need to guide it to reach the final output. Or if I have to say, to reach the correct final output. Otherwise, it will hallucinate or not, and it will hallucinate. There is no doubt about it if you don't guide it by proper steps. So what we have done here is, we have attached a lot of metadata with the QA pairs we have created. So for example, let's say there is one solution within procurement, solution one. So for that, some relevant metadata will be there. That we are calling it as area. Apart from that, when the user asks a question, how many examples to fetch to pass it as few short examples to the LLM. So basically, we cannot just send out one example and ask LLM to understand the context of the user query. So this is a dynamic parameter, number of examples. It can be changed based on the solution where the whole architecture is being deployed. Then determine the category of the question, or if I have to say, what is the type of question being asked? It is related to spend, it is related to some savings opportunity, is it related to the unit rate of a particular material, those kind of things. So you do all those stuff, all these 4 steps, and then filter out the top and number of examples which are above a certain similarity threshold. We cannot say user asks a question, the similarity comes out 0.5, and we take top 5 question 0.5, 0.4. This is irrelevant. Basically, those are not related to the user question. The context is not same. We have to put a threshold. Let's say, if you are getting some QA pairs above 90% similarity, then take those and pass it to the LLM to generate the SQL query. Otherwise, just say that the answer cannot be generated instead of hallucinating and generating the wrong output. And the idea here is, since we are dealing with numbers here, which basically forms the basis of actions, or you can say actionable insights, the numbers cannot be wrong. The reason being, if it is wrong, people trust it and they can take wrong decisions based on that. So to avoid that, we have that above a certain threshold, above a certain similarity threshold, if you are not getting minimum number of examples from the vector database, don't generate any response. That's the way we are trying to avoid hallucination here. Post that, if you basically have the n number of examples, few short examples above a certain threshold, then there are some business rules present. Because each domain, each solution will be having a certain if-else conditions, or you can say constant business rule, which has to be provided as a prompt to the LLM, so that it can follow those instructions and generate the proper response. Post, if we have these number of examples, we go there, we fetch the business rules, and then basically from that, filter out the top n examples which are above threshold, similarity threshold. All this information, the top 5 example, top 5, 7, whatever you select based on the solution, and along with the certain business rules, all these are passed to the LLM as a prompt. So that's why they are dynamically retrieved from the vector database. It's not like constant, you are selecting all 5, only the fixed 5 questions. It depends upon the question what is being asked. It is being dynamically retrieved. The whole information is then passed to LLM, which generates the SQL query. Now, to avoid, I think most of us are aware about voting a mechanism or bagging in the traditional machine learning. So we generate 5 outputs. That's what is called self-consistency. We are using a single LLM to generate, with the help of same instruction, we are generating 5 outputs. We kept the temperature a little high. Temperature is a hyperparameter for any LLM. We kept it a little bit high so that there should be some variation in the generated output. We perform voting on the SQL query based on the output of the SQL query, and then send it, the one final query and one final output to the, since we are using Snowflake, or it can be any other database, pass it there, select the output, and display it to the user. Post that, we have you can say feedback mechanism. If the answer is correct, user can just say thumbs up, thumbs down, thumbs up. That question automatically gets added to the QA pairs which we have here. So that this portion keeps on getting updated without our interference. We do interfere once in a month or twice in a month when we filter out all those wrong questions and we see where it is going wrong. We take care of that in that time frame, not every day. This is how the high-level architecture looks like. I will quickly move towards the data ingestion piece. So this is how the data ingestion looks like. We have the SQL QA pairs in the form of JSON. We'll create embeddings and load it into a vector database. So One additional thing which we have done is instead of giving the actual name, let's say you are talking about plant A. So we are masked the A because when you give information about the names of a plant, kind of entities, or let's say something else instead of plant materials or anything, any other entity kind of thing, it dominates when you are doing the similarity because there will be embedding for this also, for the entity also. So we have masked those actual names and all with a generic tags like supplier, plants, vendor, manufacturer, any other thing, okay? That's how we have masked it. So this portion becomes completely irrelevant when we are creating embedding and finding the similarity with the user query. That basically generalizes this particular question or the context of this question when you are fetching the similar questions out from the vector database. This is the data ingestion process. Now let's move forward with the SQL generation. So there are few other dynamic tables which we have maintained. One is called configuration, where you are dynamically putting like what kind of similarity threshold for which solution you want, how many number of examples to fetch for the dynamic few short prompt. Let's say you want 5, you want 3. It can, any number can work for any other solution. It is not generic like you always pull 5 examples for this solution and it will work for another one. So we are maintaining this. Based on the solution where the chatbot is deployed, it will take the parameters from here. Then there are some certain business rules which I already talked about. Which solution where, let's say we are on solution 1, the chatbot will fetch the relevant business rule for that solution, not all of them. The user question is obtained through UI. Again, post that we do the QA pair filtering based on the similarity and generate embedding for the user question. The third step is we select the few short example above a certain threshold. We decide the category of the question, which solution it belongs to, all those stuff. And category is important because let's say you are on solution 1 and it contains information about a lot of things. But when you are fetching, let's say, top 5 similar examples, it can come from spend, it can come from rate, it can come from price, anything. But when you define the category and let's say you decide the category of the user question, you only pull few short example for those category of questions, thus reducing the context hallucination over there. It will not be generic, it will be bounded to that category only. Now post that, we construct prompts, obviously the business rules which I talked about. Moving forward, we generate SQL using the LLM. Hallucination mitigation, this is the important one as I told. The number of examples pulled from the vector database has to be more than the minimum number of examples so that it does not hallucinate, it does not generate wrong response. The numbers are critical here. Now, post that we have self-consistency, sorry for that, and we generate 5 to 7 same type of SQL queries with the help of single LLM. That's an improvement point over here. Basically, we can try cross consistency over there. We can use multiple LLMs to generate similar type of, same queries. And then we can decide based on that which query to select. Now, in case of error handling, there is a SQL syntax checker enabled in between. There is a layer of SQL syntax checker because sometimes LLM generates some additional keywords like SQL or some quotes and all which are irrelevant. That SQL checker takes care of the syntax. It cleans up all those irrelevant information and passes it to LLM to generate the final output. Now, these are the results which we have achieved. We have tested it out on, I mentioned 5 solutions. And the accuracy is, using this approach, is always above 90%. For few, which I mentioned, it is reaching around 93-95%. I've divided the solution into different categories. So this is solution 1, let's say 1 report. Within report, we have these kind of information available. So for this solution 1, this kind of, what I talked about the category of the question, these are the category. We have tested around different categories, huge number of question set, and this is the accuracy which we are getting. So the one which I told, where the number of examples are less, not enough data for training, this is keeping the accuracy in check. Because if this moves to wrong answer, the accuracy will drastically drop. That's the whole reason we are keeping that constraint to keep the hallucination in check. Now moving forward with the post results. The major limitation I think everyone would have noticed here is to create the QA pairs. That will require a lot of effort. Now, what we are doing as of now, okay, there is some dependency of keywords as well, supplier, material, all. But now what we are doing, this is till when the paper was written. So now what we are doing is we are first of all exploring cross consistency, and we are creating a data dictionary. That data dictionary will be passed in the form of metadata to the LLM, so that first of all we don't need these supplier material kind of keywords. Like what is the spend for material X? We don't need to write material. What is the spend for X? Using X, it will determine it is referring to material based on the data dictionary. Another thing is the QA pairs will be reduced, because let's say you're talking about spend, even if the question is not there in QA pairs, the data dictionary will contain information about the column name spend and what it refers to. So by default, when the question is about spend, it will, even if the QA pair is not there, it will directly understand from on the basis of data dictionary that yes, this is referring to this column. We have to calculate the total sum of the spend for a particular material, and will generate the response. This is the current one. And obviously, as we scale up, for some solutions, we need 5 tables, 10 tables. So I'm coming to that. We are incorporating agents in that to decide which table to select based on the user question. So for now, we have tested around 2 to 3 tables. We are scaling up to 5 to 10 tables for every solution, iteratively, testing one solution at a time, and incorporating agents to decide, let's say based on the question asked, which tables to hit. We need these 2 tables, bring those, and generate the SQL query. This is all about it. Now the last one is the acknowledgement. Obviously, these are the guys helped us in building the system, not functionally, but basically from the domain side. Few of them are from procurement, few of them are from supply chain. 1 or 2 guys are from the core technical team, which helps in, because it started when the LLM starts coming into picture in the last year, in the early last year, early 2024. So it was not that popular, the RAG framework, but so the few of the guys here from core technical team which helped us in building this, and they are still helping us in utilizing these agents and all to incorporate this into RAG framework. Okay, so I'll take a pause here and open up for questions. Okay. Mike.
So I've also kind of developed a similar framework. But my question is, let's say we are asking to generate like a historic data points, right? Like let's say for 2-3 years. What is the most efficient way to embed like a autoregressive model to kind of forecast or predict in the future?
Okay, the scope for this solution as of now limited is to retrieve the information, not to predict anything. Okay. Another thing, I will give a disclaimer here. For any such solutions which we are developing or any of you guys are developing, the scope should be the response should come within a minute. If your query takes, let's say, 15 minutes to generate a response, that's not the ideal use case for this. It is meant for quick retrieval of insights. People will not sit there for 15 minutes and see the bot to get the response. That's the use case here. Enhancements, one more enhancement which we are doing is, few questions are related to trend, so it can generate graph, basically the trend information, which can be more intuitive in nature.
Yeah, hi.
Okay.
I think the first question you've already answered, but still I'll ask it. So when you're scaling to multiple tables across multiple DBs, here I think everything is residing in Snowflake.
Yeah.
So now if I want to create a multi-turn question answer system in response to, let's say, 2 turns before, how would we scale up to something like this?
Okay, so I'm not sure if you know or not, but in LLMs, there is an option of chat history, which retains the context. It depends. Different LLMs perform different ways. But for us, we have tried till last 3 responses. It retains the context, but the performance degrades. Because every time you have to clear chat history if you have to go ahead and ask a new question from a different context. So for now, we have disabled it, but we have tried it out. It was working well for 1 or 2 previous questions, but as we move to 3, the performance starts degrading.
No, so within the inherent table relationships and joins within existing tables, it's an issue. right?
For those, it is working fine. You can provide those multiple tables in the data dictionary in the current one. In the previous one, we used to have the QA pairs where you are having joins.
Yeah.
And it will consider based on the, let's say, top 5 examples you took, based on the SQL queries of those top 5 examples, it will take up those queries, understand which tables are required, fetch the information from those relevant tables.
Okay, one other quick question. So when it comes to the visualization, which is returned to the user,
Yeah.
so how are you taking care of that? Is there like an intermediate Python script which does it, or?
Yes, as of now, there is no visualization. There are 2 LLM calls. I am basically aggregating those 5 LLM calls for consistency into one. Another one to generate the insights. You get the number, what it means. So LLM will take care of that based on the business rules. Like this is my the savings or the spend for that material in USD in that much time frame and all.
Okay.
So it interprets it for you. Next target for us is to generate the graph of it.
Okay, that's the next step.
Yeah.
Hello. Yeah, this side.
Which
Hello.
side? Okay.
Yeah. So instead of checking the similarity of the user input with the QA data, how about fine-tuning the LLM on the same QA data? Like how does that approach compare?
On how many solutions you will find tune?
I think there are some open source data sets available for that.
That's very generic.
Okay.
What I'm talking about, not the generic data set. You know the naming conventions of humans. When you create a database or table, do you even care what name you are giving to the column? You will write something and how it will understand if you train it on a generic data sets. And like that, thousands of tables are there. How many LLMs you will fine tune?
But won't this approach have the limitation that whenever a user asks a query which is not very similar to the data set which we have given, in that case, it won't be able to give an answer, right?
That is still fine. But fine-tuning LLM, it costs a lot. And first of all, this kind of solution is for quick retrieval to smoothen the process, not to generate revenue. Okay, that's where it is.
Hi,
I,
Utkarsh.
I,
Hi.
yeah, you can continue. I have a counterpoint to this.
Yeah.
First of all, I work with SAP data. Okay, so the table names are acronyms. They are not in this ones.
Yeah, I work with
Okay,
SAP data,
that's
so I can
first thing.
link.
So, as you mentioned, okay, the data set for fine tuning can be curated. It can be curated, and with the limited resource, it can be fine tuned. Because I have done that.
No,
So it's,
on SAP data you can do. But let's say SAP is your raw data and you are utilizing it to create different tables. I'm talking about hundreds of thousands of tables which are created using SAP data and the columns are renamed into something.
yeah, so it's possible.
How many LLMs?
You just have to take one LLM.
And you can.
Okay, and you have to use a template-based question answering.
Okay.
So template-based will help you exactly narrow down which table. Okay, and so that the answer part will narrow down which exact table. The question part you have to ask LLM to paraphrase. For example, material table. Okay, say that material or there are tables like VBPK. Okay, so that's answer and.
Okay. What
It's
I'm trying to
possible,
tell
that's
is,
what I'm saying.
It's possible, but the table which you guys are referring to, it's very generic in nature. Those type of tables, you can definitely go ahead and fine tune. What I'm telling you, the target table here is completely derived from those raw data, multiple tables of raw data, and these are the reporting tables. These are not the raw data tables. Reporting tables,
We
you
will
do
discuss on this.
we
Actually.
can have a discussion.
Hi, Utkarsh. One question.
Okay.
Yeah, one last question.
Yeah.
So I think I missed it when you presented, but I think that there's something very trivial like changing the data type of one column.
Yeah.
So in this case, it might fail because I don't see in your pipeline something like a schema retrieval or at least a metadata
That is
on
in
the
enhancement
database
piece.
schema.
Yeah. Till then, when the paper was written, it was not there. You are correct.
Yeah.
Now, when we are incorporating new changes, the schema, when I talked about data dictionary, I'm not sure you were there or not. In the data dictionary piece, we are mentioning what kind of data is there in this column, so that whenever you LLM is generating a SQL query, it can take care of that piece. So that is coming as enhancements in the upcoming one, in the new one. So this we are taking care of. Yeah.
All right.
Yeah, hi.
Okay,
Last
I think we'll wrap up the Q&A now.
Can
You can catch up with Utkarsh outside the hall.
Yeah, sure.
We have to move on with the next presentation. Thank you, Utkarsh. Thank you so much.